as you saw in those last clips, normal water bottle refill stations that are in buildings like this have a lot of downsides to them. That's why we came up with Precision Pour. Precision Pour is a contactless water bottle refill station. What this means is that I can hold my bottle here or place it down if I choose to, and I can fill it up to my desired amount. The way this works is that once the bottle is sensed by the photoresistor and my hand is sensed by the ping sensor on the side, I can fill it up to however much I want it filled. This has a lot of benefits to it. You're not wasting water. You're not getting water all over the bottle, all over your hand, or all over the system that is present. You're also saving money. You're saving power and energy because of the water that is not being wasted. As you can see here, when I put the bottle in front of the photoresistor, put my hand next to the ping, it is filling up. When I'm ready for it to stop, all I have to do is remove my hand. That way I can fill it up as little or as much as I want to. In addition to our normal way of filling up the water bottle, we also have a second fail-safe method. This is using a Gertzel algorithm. The way the Gertzel algorithm works is that it is detecting the frequency that is made by the water filling up to the top of the water bottle. It is detected using the microphone in the top of our structure. The way it works is that when my hand is in front of the ping sensor filling up the water, if Gertzel detects that the water is all the way to the top, it will cut it off once it hears that certain frequency. This is made in cases where you have a metal water bottle or a water bottle that's really tall and you can't see when it's completely full and you want it to that level, but you don't want it to overfill. Now let's see how it works. So, as you saw, I put my hand in front of the ping and it was filling up, but it detected that frequency that was made once the bottle is getting near the top and it cuts it off, even with my hand in front of it.
All right, so let's have a look at what makes this thing tick. Everything back here is fundamentally 5 basic devices / sensors. And it's all powered by its first device, this Arduino Uno. This is the brain of everything. It's what tells the pump to flow when, it's what detects the sensors, it's what does everything. The other second device is this pump. This is the only mechanical device in this entire system, and in the event that it gets moved up from being a prototype and it becomes a large-scale device, it would be a very different pump with a very different reservoir. And then we come to the other 3 devices, which are all electrical based, which includes this ping sensor right here. This detects the relative distance between it and anything off to the side of the device, which is what allows your hand to be 4 inches away or closer, and then it sends a signal back to the Arduino telling it that. However, all of that, as far as the code is concerned, is blocked behind the photoresistor that comes in through the back. And what that does is it detects the ambient light in the room, and then it detects the shadow of the bottle being placed in front of it. And then finally, we have what goes up here, which is our Electret microphone, and that runs the Gertzel algorithm. This was talked about briefly. The Gertzel algorithm is a process that sets so the microphone will only be looking for very specific frequencies. Whenever we did so with our bottle here, we set it for 900, 1000, 1100 hertz frequencies, so that way, as soon as it heard it, everything in the system shuts down for 10 seconds. And all of this is brought together in this Arduino, in this breadboard, making everything cleaner. Additionally, we have obviously our nozzle in the top and a nozzle down here. These are both required because we're using water. This one at the top is so that way the pump can actually flow, and this one at the bottom is for whenever you want to pour out water, you get too much water in your bottle, you don't want to have all of it, so you can pour it into our grate in the front and it'll flow out into the back. If this were a larger scale device, it would have a actual exit place, but for the sake of our demonstration today, we didn't put a exit place.